this is our X-ray circuit model. Me and Bree will be talking about the primary circuit. The main power switch just simply turns the power supply on and off. And then the incoming power supply, it needs to be a consistent 220 volts, and at first it's not. So that's why there is line compensators, and the line compensators are wired to the auto transformer, which will automatically adjust the power supply to the X-ray machine to 220 volts. Also part of the primary circuit is the circuit breaker, and this protects against short circuits and shock hazards, and it opens and breaks the flow of electricity.
Alright, and then as for the auto transformer, which is what the line compensators are connected to, so as I think she just mentioned, it is an adjustable transformer, and it's controlled by the KVP selector, which is on the operating console. And so since you are selecting the KVP, it's self-induction, unlike these two, which you'll learn about later, is mutual induction. And the primary purpose of the auto transformer is to provide a voltage that will be increased by the step-up transformer here to a kilovoltage. And the KVP meter is what's going to be monitoring the voltage. And then we're going to go to the exposure timer, which is on the primary circuit because it's easier to control a low voltage rather than a high voltage. So that's why we're going to discuss it here instead of over here. And there's many different variations of it, but its main job is to work with the rheostat, which Danielle will talk about later. And together they determine the quantity of electrons boiled off the filament and available for X-ray production. So lastly, in the primary circuit is the step-up transformer, and that is going to be, we kind of tried to label it up here about how it's in both the primary and the secondary, but just for the sake of the video, we're just going to talk about it in the primary. So this is, as I said earlier, just what brings this voltage into a kilovoltage so we can have X-ray production, and it's not adjustable like the auto transformer is, so it increases the voltage by a fixed amount. And then we're going to go into the secondary circuit with Alexis.
Okay, as Bree said, the secondary circuit starts with the end of the step-up transformer, and we do not have a model of the milliampere meter, but so it's not displayed, but it is located within the secondary circuit, and it monitors X-ray tube current. The rectifiers are needed because they convert AC to DC. They allow for the current to flow from the anode to the cathode, and for the electrons to travel from the cathode to the anode. The X-ray tube is an electronic vacuum, and as you can see, we use a liter bottle for our enclosure. It consists of the anode, cathode, and induction motor, and is usually encased in glass or metal. The anode is the positive end, and the cathode is the negative. The two major parts of the motor are the stator and the rotor. So the stators are located outside of the enclosure, and the rotor is within the anode, so the stators rotate around it. The stators are energized in opposing pairs and induce an electric current in the rotor. The rotating anode is turned using induction motor to operate through the mutual induction that Bree was talking about earlier. And the cathode provides the source of electrons needed for X-ray production, and it also consists of the focus cup and the filaments, which leads into the filament circuit. Danielle?
So starting with the filament circuit is the rheostat, which is a variable resistor that is controlled by the MA selector on the operating console. It's responsible for the amount of resistance and current in the filament circuit itself. Then we have the step-down transformer, which you heard earlier is a mutual induction, which means it is basically increasing the current by reducing the voltage that is applied to the filament. As voltage decreases, current increases. That's why it's mutually working together. And that concludes the filament circuit.